I would like to welcome the next project and the next presenter. It's Tiberiu Lepadatu. He worked on a project on HPC performance profiling tool, and he will explain us more what his project was about. Tiberiu, the floor is yours. Welcome.
Hello, thank you very much. Let me just share my screen and I will start. I share the screen, desktop 2, I think so. No, desktop 2. Okay, this one. Can you see the presentation?
Yes.
I hope that everybody can see it. Hello, my name is Tiberiu Lepadatu. And this summer I've worked on the project called Profiling Tool for the IFS Performance. And I really want to say that it was an amazing project, an amazing opportunity, because I had the opportunity to mix some of my passions, one of which being the understanding of the data, the second one of which being helping people in the HPC community, in the high performance computing, and also doing it for a noble cause, which is for weather prediction. I also like to thank my mentors, Olivier and Michael. I don't think that anything would be possible without them helping me understand the metrics that they were into these projects. They were amazing, and thank you. So let's start this presentation with some questions. Why do we need a custom tool? This is, I think, one of the biggest questions for this presentation. Well, we know that IFS generates bespoke performance metrics. They use Dr. Hook in the IFS, which is a very peculiar way of getting performance. So it's logical that we need a peculiar way of profiling weather models. So we need a peculiar way of understanding the information. I'm going to show in the next slides how the information is understood right now and how it will be understood with my project. It's important to have to have data from the weather prediction, and each second that we spend analyzing the code, it's time wasted, because HPC performance is very important in the weather prediction community. Very many countries around the world spend a large amount of money when ensuring that the weather tools run very smoothly and very fast. One of the biggest challenges was the application design, because we wanted to do an application that was very beautiful, that was done in JavaScript, that the front end was done in JavaScript, and extensible with Python plugins, because usually the people from the IFS community are researchers or people that work in performance optimization. And they don't know the industry standard. They don't know the industry stuff, for example, JavaScript. They are not working in that domain. So they work in Python, which is much simpler language in a way, and because it gives you the possibility to do the kind of metrics that they are using very easily, and JavaScript has some very annoying errors. And this is the reason that we've created the application to be extensible from Python plugins. So nobody really needs to know JavaScript. Also, we wanted the application to be very extensible, very flexible, and to be able to integrate it further in the IFS continuous integration pipeline. Right now, the project is proof of concept. It just demonstrates and showcases how the project could evolve. And I really want to point out a saying that one of my managers had when I worked at a startup. The project right now, it's in a state of manageable chaos, which I think is the best word for it. That's why I've prepared the video for the demonstration, but I really hope that it works. Everything in here is configurable. You can write your own story. You can create your own graphs. Everything just by moving some tiles around. Everything is great. So let's see how it was before my project and how it is right now. Right here are the, it's a picture of a CSV that people use right now in profiling the IFS. And you can see here on the top that you have the wall time, the total cycles, the L1 data cache misses, L3 total cache misses, and so on. So those are metrics that people use to profile the data. On the right side, we see a very interesting graph that you have here that I've created just by clicking those tiles. And you can see here that I've chosen four routines. And I can see that Cloud SRC, it's a very big routine and so on. It takes a lot of time. But on the right side, we can see this spider web that I'm going to better present on this graph right here. And the interesting part about this spider web is that you can see why the routines are like this, why the time is like this. And something really interesting, it was actually yesterday when we were testing, is this graph right here. Because you have here, you can read Cloud SRC ECPOR PAPIC, right? And here is Cloud SRC ECPOR HOPT. HOPT stands for optimized routine. And we can see that the optimized version of that routine takes longer. It has more total cycles than the not optimized one. So this is something really interesting that we've managed to figure out. We managed to highlight using this tool. So we kind of helped the performance specialists to understand that there may be a problem, that there may be a bug in there. Also, we can see on this plot the vector DP, which is vector double precision. We want this to be very high because this is calculation. There are the processor does not stay. By the way, all of those metrics are done with hardware counters. So this is another reason why we are not using something like Intel Parallel Studio or Scalaska or something like that. Here it's L3 total cache misses, L1 direct cache data cache misses. We can see that the data cache miss is actually larger for the optimized version. So this might show a problem. Right now, as I said, I have a video for the presentation in case of a disaster. But let's try to do it live. Like I really want to do it. So this is the dashboard that you have when you start, and let's create a new source. Okay, you can move around and so. And we want to add some columns to display. Those columns are what you want to display, for example, L1 cache, L2 cache, and so on. Right now, you can see that you cannot click on here because you've not selected what you want to plot. You want to plot, for example, the ECPROF PAPIC, right? And we want to look at, let's do a sunburst. Then we create a filter so that we can select the rows. And let's look at Cloud SRC, at this one, and CPG. By the way, CPG, it's a very interesting one. By the way, if you add something that you don't want, you can just remove it and everything works like so. And then we can add it all into display. Right now, the display that I'm using, it's a sunburst, but we can just, at a flick of a button, we can change to a roofline. The roofline takes a little bit to load because everything is done on the server, and then we can add something else. For example, L1 direct cache, data cache misses, L3 total cache misses, L1 ICM, and also let's change it. Let's not use wall time. Let's use something else. For example, total cycles. And we just erase that from there, and the graph updates. And then we want vec DP as well. So we've got this graph, and we can open it up. We can look at it, include it in a report or something like that. But let's say that we want to compare it with something. So we are just adding a new data source in here, for example, the optimized version. And like that, it's just, you just have the graph. But for example, you have another data. It's not a problem. You are just static it in here. Right now, I can just stop the one that I had before, for example, the cry metric, the one that is not optimized, and just look at just the optimized version. And you can see here that it's a matplotlib graph. We can also select those up. Wait a second, because I need to select a little bit more than those. Move them around and creating here another graph. For example, for the optimized version, we can select some columns, I don't know, wall time, let's say, and do a sunburst, like so. So everything is configurable, everything is done just from this interface. But everything does not start there. It's actually starting in a Jupyter Notebook experiment that I have on my GitHub. And you can experiment in here. If it loads, it's loading. OK, you can experiment in here. You are creating your graphs in here. And then just for, I don't know, 10 lines of code, you can add those graphs into your application. Let's continue with the slides. So how have I done it? Like I said, it was a very big problem for me, the way that the application should work. So I have a Jupyter notebook that we use for testing, for prototyping. We're creating stuff in there. Then we are just copying and pasting the cells from the Jupyter notebook to the Python server, Flask server, by the way. And on the Flask server, this can be linked to the IFS database that can run in the continuous integration service from the IFS. And then you need to change just what you have on the server. Nothing on the client should change. Then you have the React client, which is the interface that I've just showed you. And the interface is configurable. You can change everything in there, but you don't really have to. The only time that you need to change the interface, the Jupyter Notebook interface, is when you want to add some new selectors. And I'm going to show you on the next slide what we are working right now on to. So the future of this project is very simple. If you want to add some new graphs, you are just writing Python. There's nothing more to it. But if you want to add another kind of selector, for example, what we want to add right here, and right now I'm going to explain it to you because it's something really amazing, you are going to need to write a little bit of JavaScript. By the way, let me just 1 second, excuse me, so I can present with the notes. More present, like so, okay. Okay, I have my notes in here. So you can, what is this graph? This graph is the graph that you have, the call graph that you have for the functions. And what we want to do with it is clicking on a single point or a single routine or subroutine and selecting entire trees of code and having a cumulative measurement, cumulative metrics of that point. So you'd have something like a reducer that can be used to do something like, I don't know, like selecting the maximum subroutine time for a subroutine that is called from that point, selecting the minimum time, selecting a summation of them, and so on. We are right now working on this. We've done the graph. We've created it in an experiment notebook. And right now we are working on integrating it as a new selector in the platform. It was very nice for me to talk to you, and I thank you very much. And in the end, I want to remind you and to leave you with just one very important idea. That this project is not creating something new, is not creating the metrics or taking the metrics from the hardware in a very particular or very interesting way. It's just taking the metrics that we are taking from the IFS and presenting them to the developers in a very interesting way, in an innovative way. So we, on the one hand, are going to highlight where the performance issues lie, and on the other hand, we are going to make the developers, the performance guys, more productable and let them spend less time on analyzing the code. We are just going to show them a graph, and they can go in there and be like, yes, this is a problem, I'm going to investigate it further. Thank you, and I'm waiting for your questions.
Thank you, Tiberiu. It's, yeah, again, also as the first one, very impressive what you developed. I have a question, what I didn't entirely understand. What is the link between the Jupyter Notebook and then the Python server?
Okay, Python server runs on the, by the way, I forgot to mention it, and I'm sorry. Python server runs on the weather cloud right now. So if you want to get the code from the Jupyter Notebook, you are just exporting a cell. You are copy pasting a cell into the server, and then you need to edit a JSON file so that the client knows that the information is there on the server, and that's all. So it's like you have 2 steps to do, and you are adding a new kind of graph on the client. For example, the way that I'm selecting right now, the way that I'm adding new data sources and so on, was done this morning. So yeah.
Okay, so basically the Jupyter Notebook is, so you could also take any type of Python code. It doesn't have to be a Jupyter Notebook. It's basically a code where you develop a new visualization.
Yeah, but it is not necessarily Python code, by the way. You can actually have any type of code. It's very simple to write an interface for it. Because we have this architecture, the server client architecture, and most of the times the client does not care what the server does. So that's the very important silver lining, the very important point of the project, that everything, the interface does not care how the server operates. So yeah.
Okay. And so you mentioned it a bit. So are there, and so is this, you said it's like on a creative development state?
Control chaos.
On a control chaos?
Yeah.
So will this controlled chaos now be taken over by ECMWF and then developed further?
Control chaos means that meaning the fact that for example, let me just say something. So spill the beans on the project, let's say. For example, you sometimes when you are copying and pasting some cells in there, you might run into a bug or so, but it's not production level, because our goal was to develop so much, to create so much information and to show where this project kind of lies and how it can shine in the future.
Okay. We have one question, in fact, on Slido from Milan. He asks, Tiberiu, did you find other performance bottlenecks for IFS? You mentioned, for example, an optimization level that didn't actually do what it's supposed to do.
We, as I've previously told, was this we are not really sure. We have find this bottleneck yesterday, and we are not really sure if lies a problem, but the performance guys are investigating further. We've actually, yes, we've tried to look through the IFS for some parts, but yeah, the data was not. We had some access to the data, but it was kind of limited. We find some stuff, but we cannot say that they are bottlenecks. It's not a, you can see with this tool the bigger picture, but perhaps something happens in there that it's actually, this is how it's supposed to happen,